Hi everyone, my name is Mohit Jain and welcome back to my YouTube channel. This is the third installment of the PySpark dataframe series. In this video, we are going to cover GroupBy functions. GroupBy is a very powerful tool to aggregate the data based on the specific criteria, enabling us to gain more insights on the dataset. In this video, we are not only going to explore the syntax and mechanics of GroupBy in PySpark, but we are also going to cover the intuition behind the GroupBy functions so that everyone can understand what goes behind the scene whenever a GroupBy is applied on a data frame. By the end of this video, you will have a solid understanding on how GroupBy actually works and how you can use it to summarize, manipulate, and analyze your data based on specific conditions on your data sets. I highly recommend you to watch this video till the end to understand the GroupBy function effectively. So let's dive deep into the GroupBy functions. In this video, we are going to cover different GroupBy functions like count, sum, min, max, average, and pivot. We have already created a Spark session over here. Those who are not yet clear how to create a Spark session, they can go and watch my first video. They have explained how we can create a Spark session and what these different terms are. Once the Spark session is created, we have already read a supermarket sales data. This is again explained in the first video. So you can go ahead and watch that video to see how we can read different type of files using Spark. The data that we have read is the supermarket sales data. There are multiple columns available. We are going to use some of these columns to apply GroupBy operation. You can see that the date column over here is in the format of MMDD and YYYY. To convert this into the actual date format supported by Spark, I have used two date function. Multiple date functions are already explained in the second videos, so you can go there and watch how we can use two date function and other date functions to convert the date into different format. So after that, we already have this particular data available. Let me first show you what are the different columns and what are the data types. So I'll do spark.print schema, and this will give me the schema of the different columns. So you can see over here that all the columns are in the string format. We can change that using info schema while reading. So let me first read this again. And now we can see the print schema over here. You can see that the unit price now is in the double format because the price is in the double format. You can see over here 74.69. We are going to apply the GroupBy function on different columns. So you can see over here that we have columns like product line. So product line may be health and beauty or electronic accessories or home and lifestyle. So there are multiple categories available over there. And you can also see that the transactions that we have are of a specific date. So before directly jumping into the syntax of GroupBy functions in PySpark, let's first look into how GroupBy can be used in different use cases and what goes behind the scene whenever we apply a GroupBy. Let me create two columns. So there is one column called as a payment, and then other column is called as a date column. So in the payment, we can have multiple values, transaction dates. So let's say this particular was happened on 1st March, and let's say we have another transaction for e-wallet for the 1st March. So to calculate how many transactions happened for a particular payment mode, we can use a GroupBy. So how the GroupBy actually works? So we can do a GroupBy on two columns because we want to know how many transactions were happened via e-wallet on the 1st March. Similarly, how many transactions were happened for a cash transaction for the 1st March. Similarly, for the 2nd March as well. So what will be going behind the scene is, it will first group the data together. Let me write the date column first. We'll say there is a date column and there is a payment column. And let's say 1st March, we have e-wallet. So this will be over here. Again, we'll see that are there any other e-wallet transaction on 1st March. So we can see that this transaction is again on the 1st March. So again, over here, we will write that this is on the 1st March and the transaction is the e-wallet. So we can see this combination cash and 1st March. So it will again get grouped together over here. And we can write 1st March and cash like this. And if there are other transactions, so there is a credit transaction as well. So the credit card is also used as a payment mode on the 1st March. So we write it like this. And then on the second March, we can see that there is one e-wallet transaction and one debit card transaction. So then we'll have the second and e-wallet over here, and second and debit card over here. Now you can see that once the data is grouped, so the purpose of group by is to first group the data together. So if we are saying that we want to group by these two columns, like a payment column and a date column, it will group the data together, and all the values for that particular group will be sorted in one way. So you can see over here that we first have the transaction of the first March and e-wallet, similarly then cash and then credit, and again on the second March we have different transactions available. Now if you want to count the number of transactions, so what it will do, it will create one more column, let's say, and then it will apply 1 to each of the rows over like this, and finally we are going to sum this. So you can see that we have a first March and e-wallet in 2 rows, so the count will be 2. Similarly for cash also we have 2 rows, so the count will be 2. For credit we have only 1 on the first March. Similarly on the second March we can see that on the e-wallet we have 1 transaction, and on the debit card as well we have 1 transaction. So the process will be, in the first step there would be a group by. You can pass only 1 column as well. For example, if I want to know historically how many payments were made via e-wallet or cash or credit card or debit card, so we can use a group by function on only 1 column, and the same process will follow. It will first bring all the data for e-wallet together. It will assign 1 to all of the rows, and then it will apply the sum on the count column. So the count column, this is a pseudo column that I have created over here to explain you. If the use case was that I want to just count the number of e-wallets, there will be only 1 column, so all the e-wallet will come together, e-wallet over here. So we can see that there are 1, 2 and 3 e-wallet transaction happened historically. All the e-wallet will be over here assigned 1, 1 and 1. Similarly we will have cash, then in the cash we have assigned 1, and similarly we will have different modes of transaction as well, like credit card and debit card assigned 1. After that we are just going to count the complete group. So you can see in e-wallet we have 3, in the cash we have 2, and the credit card and debit card we only have 1 transaction available. So this is how we can use a group by. So different use cases based on how you want to aggregate your data based on 1 column, multiple columns. You can use group by, but internally it will follow this particular steps only. So one more thing to notice about PySpark is that if you are running PySpark on the local machine, like I am currently running it on my local, there is only 1 computer and we have only 1 file available or multiple file available in the data folder inside my D drive. Okay, so in this case there is only 1 machine that is going to read all the data. Even there are hundreds of files are available, still there is only 1 machine that is going to read the data. But if you are working on a Spark cluster, let's say if you are running the Spark on the Databricks cluster which has 3 worker nodes, or you are running it on different like GCP, Dataproc or EMR, you will be having multiple nodes, and then the data is located in the S3 location or the GCS location. Okay, now we have multiple files available over here like this, and once the Spark application start reading the file, it may be possible that some of the data is read by 1 particular node and other data is read by a different node. So we have data available in 3 different nodes, and let's say we have the data for home and like say lifestyle over here for the first March. We also have the data available for this particular product line here and here as well, because different files would be containing different data sets, and there is a possibility that different product line would be available in multiple files as well. So you can see that home and lifestyle is available in this particular file 1, in the file 2, in the file 3 as well. Now whenever you want to apply a group by, we want to aggregate the data, so we want to apply sum, min, max or average. But since the data is available in different nodes, the data first needs to be transferred to one of the node, so that the group by and sum average would work properly. So what will happen over here in case of PySpark when we run in a cluster mode, all the data for a particular category, let's say, or for a particular group, will travel via network to one node. So let's say there is a node 1 and node 2. So let me give this node 1, this is node 2, and this is node 3. Now whenever you want to apply a group by, let's say on the first March and on the product line column, all the data for first March and this particular product line will go to one node where we can then apply a group by. So this particular process where the data is transferred from one machine to the other machine, this process is called as shuffling. So shuffling basically means that the data is transferred via the network from one particular machine to the other machine, so that we can apply different operations like a group by or a join operation. Multiple operations like that is performed. In such cases, we have to perform the data transfer. The process is called as shuffling. So over here you can see, since the data is available in multiple places, like let's say electronic accessories is available in these two places. So whenever we are going to apply a group by on these columns like first March and electronic accessories over here, so all the data from this particular node can be traveled to this particular node over the wire. Once the data is available in one node for a particular group, like we have HA, like home and let's say home accessories or home and lifestyle, whatever be the product line, we have it available in the one node. Now we can apply different functions that we want to apply. So we have all the 100 records, let's say for example for a home accessories product line. Now we can apply different like count, sum, min, max, different operations we can apply on this particular group. So these are the two things that you have to remember, that in the case of a single machine, there is no shuffling happening because all the data is present in one machine. And in the case of distributed systems, the data, there are the multiple machines available and the data is read by different machines. So different files will be read by different machines. And whenever you apply a shuffling operation like a group by operation, where we have to transfer the data to different nodes, then only you can apply any kind of aggregation, because the first rule of aggregation is that we want all the data in one place. So this is how group by works in PySpark. And let's go into the code and apply group by on different columns. So using group by, we are going to answer multiple questions. So let's start with the first question, like how to find the total daily sales per product line. So in this case, we already have a data frame available, and we have a date column, and then we have a product line column, and then we have a total column available. So we have to look into two columns, df dot group by, and in the group by we have to pass the column name. So the first column name is say date, and the second column name is the product line. So this is the second column name. Let me copy it from here. And so once we do a group by, so based on what we have seen over here, it will first try to sort it in a particular order. So all the data that belongs to a particular group, like in this example, we can see date and payments were two columns on which we were grouping. So date, first March, and e-wallet came together. Similarly, in our case over here, we can see that the date and product lines are two columns. So date and products line will come together. It will then apply some operation, like in our case, we want to know the total daily sales per product line. There's an aggregate function already available where you can pass on the function that you want to apply. So I'll use the aggregate function. I'll say f.sum. In the sum, I'll pass the total column. Total column means that number of like how much a particular product line sale has been done on a particular day. So there's a total column available, and I can give it a name. I'll say that total sales, let me say per product line, per PL. And when we apply a dot show, one more thing to notice is that you can only select the columns that are available in the group by, because whenever we apply a group by, it only takes those columns that are in the group by clause, or else you have to apply some aggregation on that column get it selected. So in our case, we have two columns, date and product line, and the third column is the aggregated column on the total column available, and we are applying the aggregation on it. So let me do a dot show. So you can see that it has provided us the daily sales per product line. Let me show you the complete product line name. So you can see on the 28th of Feb 2019 in the health and beauty, you can see that total sale was 689 bucks. If you want to sort it in a given order, you can then apply dot order by, and the order by you can say that I want to order by date, and I want to order by product line as well. So the second column is product line. You can now see that on the 1st January for electronic accessories, the total sales was this. Similarly, for the fashion accessory, you can see that the total sale on the 1st January was 621 bucks. So this is how you can sort the data using the order by function. So this is how you can use group by on multiple columns and then aggregate the column over here. Now let me go to the next question. It asks for total number of quantities sold daily per product line. In this case, we just want to know what is the quantity for a particular product line that has been sold on a given day. So I'll say df dot group by, and in the group by again I'll pass the date column and I'll pass the product line column. So the column name is product line, and in the aggregation I'll pass on f dot. Since we want to again get the total number, so we'll use the sum function. So I'll say on sum, instead of the total sales, or like on the total column, I'll use the quantity column because I want to know how many quantity of each product line has been sold for that day. So I'll say f dot sum quantity. I'll say that dot alias is total quantity, and once this is done, let us apply this show function. We have multiple product lines for a given day, and you can see that for 28th Feb, the product line health and beauty sold like 15 quantities. Similarly, for other products as well, we have the daily aggregation of how many quantities of that product line was sold on that day. So again, we can again apply the order by over here as well. So you can see that on 1st January, electronics accessories were sold 18 quantities. There is one more thing to consider, like we applied the group by on the same column, yet we use different functions, like same functions but 2 times. Instead of that, we can club both of them together. So what I'll do, in the same aggregation, I can use multiple columns as well. So here we already have the f dot quantity column. I'll just add the total column as well. So let me add it over here. So like this we can pass, and now what I have done, df dot group by, same date and product line, aggregation on some like on the total column and then on the quantity column. Now the output will be 2 columns of the group by and the 2 other columns that we have created using aggregation. So once I apply this, you can see that we have total sales per product line and total quantity, and you can compare it over here as well. The values are still the same because we have applied the same function. So you can have multiple columns in the aggregation, like in the aggregation function you can pass on multiple columns and you can perform multiple different type of aggregations. So you can pass one sum, and you can also different like you can pass different function over here, like I want to know the min quantity per product line, so it will give me the min quantity as well. So let me change the name to min quantity. So you can perform multiple different functions on inside this aggregation function. So you can use sum and min, then average, different functions you can use in one go. Let's go into the next function, the count the number of payments method per day. This is the question. So let us again do a group by. This time we are going to do a group by on the day column, and so the column name is date and the second column name is payment. and we want to do the count aggregation, so I can do a count f dot count, and the count and the column name is payment. So I'll pass on the payment column over here. You can see on the 2nd of January 2019, the cash payment method had 4 count. So 4 person did the payment by cash method. Similarly, on other day, you can see that the number of payments done on the credit card on 18th of January was 2. So we can see that for different days, we have different payment methods and the count of that payment method. Let me sort it in the ascending order on date basis. So I'll say dot order by, and in the column name I'll pass on the date column, so that it is more clear on which particular day what was the payment method used. So you can see on the 1st of January we had 3 payments method. 4 person did credit card transaction, 2 did e-wallet, and 6 people did cash transactions. So this is how we can use the count method. Also, just to verify whether the aggregations are correct, we can again filter this record and then validate whether on these days what were the actual payment methods and how many number of payments were done for a given method. So I'll say df.where. I pass on the date column, and the date is 20190101. So let me apply this, and you can see multiple columns. So let us select only the columns of our concern. You can see that on 1st of January there were 6 cash transactions, 4 credit card transactions, and 2 e-wallet transactions. And you can see over here as well, once we did the aggregation, there are 6 cash transactions, 2 e-wallet, and 4 credit cards. So this is how we can use the GroupBy function and count different payment methods on a given day. And the other use cases where you wanted to count like different genders who are doing the transaction on a daily basis, so you can use that in the gender column as well. Now the next function that we are going to see is the min, since it is asking for a least performing product line per day. To get the least performing product line per day, what we can do, we can first do the total of sales per day for a given product line. This we have already done above. So let me store it in some variable. This data frame will now consist of total sales per day per product line. So if I do a dot show, so you can see that we have the total sales per product line available in this particular data frame. Now if I want to know the minimum sale for a given day, I'll do a group by again on this particular result. I'll do a group by, and in the group by we can pass again the date column. Since I want to know for a given day what is the minimum value, we'll just do a group by date and dot aggregate. In aggregate we can pass on the min function, and we are going to apply the min function on the total sales per product line like this, and we'll say dot alias. I'll say that min product line sales. When I do a dot show, it will give me for each day what was the minimum product sale happened. So instead of doing a show, I can store it in another variable. I'll say df min sales equals this. Now to get the product line, we have 2 data frames available. Like df min sale has the minimum sales per day. Like if I do a do show 10 false, and you can see over here that we have the minimum sales per day, and we have the total sales per product line. If I join these 2 data frames, we would be able to get the minimum sales for a product line. So what I'll do over here, I'll say df underscore total sales like this, dot join df min sales. So don't worry about the join syntax. We'll have another video where I'm going to talk about joins only, where I'll tell you about the syntax. Let me rename this column as same. I'll talk to you about how join syntax works, but for the simplicity in this particular tutorial, let me give it the same name. So there are these two columns, and these two columns are common like this. And once we do a join, and the join type would be the inner join, and when I do a dot show, it will give me three columns. Since these two column names are common, so that's why you can see in the join there are two columns only available. We have the product line available, and we have the total sales, which is the minimum sale for a given day available. And if I do a order by over here, so you can see that minimum value for 1st January 2019 is 132, and the product line is health and beauty. And to validate this, let me just go into the previous values. You can see over here that when we did the total daily sales per product line, the home and health and beauty product had the minimum sale for 1st of January. So similarly for the 2nd January, you can see that we have electronics and accessories. On the 2nd of January, we can see that only the electronic and accessories product line had the minimum sale. And over here also you can see that on the 2nd January we had the minimum sale for electronic and like electronic accessories. Okay, so this is how you can use different functions together. Like we did our two group by function, first to get the total sales and then to get the minimum sales. And once we had both the data frames available, we just did a join on these two data frames, because one data frame had the product line and the other had the minimum sale. So this is how we can use two different type of operations to get the minimum sale on a daily basis. Similar to that, we can again use this for getting the most performing product line per day. I'll copy this particular line of code, and instead of in minimum, I am going to use maximum. Now df underscore, again we are going to join two data frames, so I'll again copy these two like this, and instead of min we are just going to pass, in the join condition we are going to pass the max. So let me pass the max, and once I run this, we can see that on 1st of January electronics accessories did the most sale, and we can validate it with the previous result that we had over here. So you can see that on 1st January, electronic sale did 1382 bucks for 1st of January, and we can see the same number available over here as well. So this is how you can use minimum and maximum. Now to find the average daily sales, what we can do, we can just apply a average function on the same data frame. So I'll say df dot group by, and we can group by it by date, and then we can directly perform the aggregate function, since we want to know the average daily sales across all the product line. So I'll say f dot average. Inside the average, I can pass on the total column, and when we do a dot show, it will give me the average total sales for a given day. So like for 23rd of February, average total sale was 292 bucks, and similarly for different days we have the average total sales. If you want to rename the column, you can just do a alias, and you can say that average daily sales. So this is how you can perform this. The last and a bit complicated and the most important function is what we are going to see. So the pivot function is something that we are going to see now. What I want here is I want city-wise lifetime sales of each product line, which means that for a particular city, what is the lifetime sale for let's say category like electronic accessories. Similarly, what is the lifetime sale of other categories like health and beauty, or food and beverages, or sports and travel. So the output should look something like this. There would be a city column, then there would be different product lines over here. So let's say there's a health and beauty, then food and beverage, then we have the other columns like sports, and below these columns we should have the values for a particular city. For Yangon city, I want to have the values. So for the Yangon City, the total lifetime sale for a home and beauty product, let's say it's $100. Similarly, for this particular things, they are $200, and then for the sports, we have $300. So something like this we want, and you can see that these are different columns now, but initially these were rows. So pivot function basically converts the rows into columns, and then it applies the aggregation on that particular rows. So for example, you can see that product line is a column, and we have the different products line available over here, like health and beauty, electronic accessories, home and lifestyle. So the output of pivot would look something like the city name. Then the product line is going to become a column. And for that product line, what was the total sales will look something like this. To apply the pivot function, let us apply it in PySpark now. So it's pretty simple. Like the syntax is same, df.group GroupBy. In the GroupBy, I am passing the city name since we want to group it by city. And then I am going to pivot it. So I am going to pivot on product line column, since on the product line column we want to create new columns for each product line, and inside, like below the product line column, I am going to show the value for each city, and I'll do aggregate, and inside the aggregate I'll pass on the column name. So I'll pass the column name like f.sum, and we have the total column available. And let me just apply and do a dot show. Now you can see over here that we have only 3 cities available, and there are different categories, and for each category's total lifetime sale is what we can see in this particular row. So we have new columns for each product line, like electronic and accessories, fashion accessories, food and beverage, health and beauty, and below each column, like for each product line, we have different values which represents the total lifetime sale for a particular city. So this is how you can use different group by functions, and all the use cases where aggregation is required can be simply done using the group by and the aggregation functions that are available in PySpark. Before you go, don't forget to watch out the previous videos on PySpark data frame series. Each video is going to help you improve your skills on PySpark. So please take a moment and browse through a PySpark playlist and catch up on any videos you have missed. If you found this video helpful, don't forget to hit a like button and subscribe to my YouTube channel. If you want me to create a video on any other topic, please drop a comment below. Until next time, happy coding and stay curious.